Hello friends, welcome back to my YouTube session AI for .NET developers and tech leaders. We learn and build AI solutions in the real world. So here I'm recording my weekly sessions for you. So let's coming back to our session. In the last session we talked about deep learning and how you can utilize deep learning in ML.NET. So there were we talk about transfer learning. So that's a small recap. Let me give to you the transfer learning. This dedicated video I recorded. This is the playlist, in fact, and this video you can, if you are new, you can have a look on this video. Transfer learning for image classification or whole playlist I prepared especially for you guys in the deep learning. So you can start with the deep learning fundamentals and step by step deep learning how we can use in the ML.NET. So one thing was very clear, because in the ML.NET you will not building your deep learning model from scratch, but you are utilizing. How you are utilizing? You are using transfer learning. It was fantastic. The last session we use ResNet. This is the recap. We use ResNet, and using the ResNet we categorize the image. Then we trained our model. Last layer we trained for the model, and we predict from that. That was good, but today I have interesting and something very new for you. The new is, let's say we train and we classify images, we classify image classes using ResNet, but now we will do something out of the box. Out of the box means we will detect object in the image. We will do this, and how we will detect the object will not only classify, but we will detect the object inside image. Yes, it is possible. How we can do this? Let's continue journey with me. So for object detection, there is one model, not, I would say model is not right, there is a one framework library is available. This is Ultralytics. This library, if you can look into, then they are providing many deep learning models, which models solve real world problem, as you can see here. But the question is, these models, you know what, these models are developed in Python, and that is blocking for .NET developers, because these models are developed in Python and is very useful, and within some short of time you can download those models and you can use in a Python. But the question is how it's make compatible with your .NET, because we are talking about the .NET. So the real world problems you can see over here: detecting images, detecting object from images, or detecting object in a real-time video. So that is the purpose. So the model is called YOLO. You looked at once. These are YOLO models, and these models provided by Ultralytics. So let's have a look how we can use the YOLO models in our .NET infrastructure. So there are several YOLO models provided by this framework or this company. Let's have a look our strategy, how we will continue for that. Keeping short and easy. Let's continue with this. So how we will use these models in .NET? Let me draw a diagram. What you will use? We will use, definitely I will not explain or teaching you learn a Python, but we will, smallest part of Python we will use. For what? We will use the smallest part of Python to export the model into ONNX. Now you will ask the question, what is ONNX? Hold on, I will explain. So first, what we will use? We will use Google Colab. Google Colab. What is the Google Colab? There are new terms you are learning day to day with me. The Google Colab is a platform where Google offer proper infrastructure on the cloud you can use for different language. So we will use this platform for cloud, for Python code. Okay, let's say we will use Google Cloud, Google Colab. Then what next? Then we will import. What? We will export. First we will import. What we import? We will use YOLO model. YOLO model. It could be different versions. Let's talk later. So let's say we will utilize this YOLO model. We will import into here, and then from this place we will export YOLO models as ONNX format. What is ONNX? Let me explain to you. Export into .ONNX format. This is pretty clear, I think, guys, for you, isn't it? Okay. Export into ONNX format. What is ONNX? You are .NET developers, you know cross-platform, you know interoperability. So this is exactly interoperability. ONNX is open source framework which offers the flexibility, offers the feature you can use any pre-trained model which are comfortable or which are compatible with ONNX format. If model is compatible, you can use in your .NET, isn't it? This is the beauty. So you can search this. What is ONNX? ONNX, Open Neural Network Exchange. This is ONNX portal, ONNX website, which explains you a lot of detail. That's the exact use of ONNX. We will use ONNX into our .NET, and then through Google Colab I will import YOLO models and export YOLO model in the format of ONNX. Once this model exported, so once the model exported, we will import this into our .NET. Let's say this is our .NET project. We will import this model into our .NET project. Let me do this here. We will import into .NET. And what next? Easy. In the .NET we have option is called inferencing. That is the option in .NET, inference. We will use inferencing and then load this exported model into our project and start prediction. Isn't it? It seems magic, but not. It's not magic. This is the pipelining. This is the complete process. Let's have a look. Once you export, then this model start prediction. How? Like this. So our model, YOLO model, we will use Google Colab, use UltraTelex libraries, install it into Python, export the model in format of .ONNX, use the ONNX runtime in .NET, and then import this model into our project, that project built in .NET, and then start prediction. So once you do this, this model will start prediction like this. I will explain you the detail of YOLO models, but before this I think we should do our practice, or we should know how to export it. So let's continue. Let me open Colab. You can use Google Colab. Google Colab is open source. Yeah, it's provided by Google. I already created some notebooks, so you can create your own notebooks. The format is IPYNB. Yeah, this is interactive file. That's basically interactive Python notebook file. Let me open this. So Google Colab gives us a lot of flexibility. So I already created this file to save our time. What is here? Let me explain. This file, we use Python here in this file, and here you can see connect. So this is basically your runtime will be connected. I hope you already know about the runtime, because I already used IPYNV extension in previous sessions. So this is easy. This is our runtime, a framework. What runtime we use the Python here. So you don't need to learn Python. That's first and important thing I would like to clarify. What you need, that I will show. So you need to understand, this is pip install ultra ultralytics. This is installation. It's simple as you install, as you update in a .NET. So let's do this installation. So it will be downloaded. This Google Colab is fantastic. It's really very useful for research and for academic purpose, but I think not good for your industrial purpose. So for that you need to build your program. But here it is pretty clear, because I'm not going to use too much about this Colab. Our mission for Colab is how I can export YOLO model into ONX format. So here so you will always get the updated latest YOLO model if you do this, and then you can export it. So it's easy for you guys. Here a small code we need to write. This is namespace. So from Ultralytics I'm importing YOLO, and then YOLO your model name. So this is my model name. I'm using YOLO 8, and export format ONX. This you will do once you click on this icon. So this Colab will export the model. You can see over here the model will be available here very soon. So I'm exporting 8. There are many models. Start from 1, 2, 5, 8, 11 till recent they have 26. So there are many models available, but based on your uses, what uses you want. Okay, can you see the model is available here? There is a PTS PyTorch model as well available, but I will not use this. We are using ONX, Open Neural Network. This model is exported. Would you like to see the magic here? How this YOLO will work? How this YOLO will detect the object? Let's see. Okay, let me have here I created a small program. What I did, I use computer vision. So this is the computer vision. This overall program is belongs to computer vision, because we are detecting object inside image. That's definitely vision. This is the computer vision CV2 library we will import. Then we will load the YOLO model. So that is not necessary guys for you, but let me show you so you can differentiate how easy and how fast in a Python as compared to .NET. But we will live with .NET only. So here at this line I'm using, let me increase font size. At this line I'm loading model, and then I'm loading my image, and then this mod will start prediction. This prediction will start it. At last this model gave us the data, means output. So here I use traffic.jpg. Okay, let me find where this image is. Okay, somehow I able to find this image. So let's upload this image here. Traffic.jpg. That image will be uploaded. Now what this program will do, this program will annotate, detect the classes, detect the object from image, and then save the image as also as an output. Let's see, and give us the prediction. So let me run this. Once I run, this program will give us, okay, in your image I found 17%, fire hydrant, bus, cars, how it looks like. Let's have a look here. It's loading, so it take bit time. let, let's continue. Okay, can you see here? So this model will detect the objects inside image like this and give us the confidence. This is called confidence ratio. How much model confident about the object? Okay, looks interesting, isn't it? I would be happy if I heard from you. Is this looks interesting for you guys? This is something new. It's something very new. So we use YOLO models, and using YOLO models in our .NET program only, we will detect object from image. Not only detecting and finding the boundary. So this is basically draw a boundary of a model, sorry, draw a boundary of object and give us the percentage, means confidence ratio, how much confidence this model have. This is not magic, guys. That I like to explain very clear. This is not magic. How this model detecting those objects, because YOLO models are generally trained on very common classes. YOLO, definitely, if you ask about a specific problem for your image, this model may or may not give you the result, because if the model does not have weights means classes. It's called COCO classes. If model does not have classes, or this model not trained on those classes which you asking, then probably there are less ratio to detect object inside the image. But this you can do. So this model already trained. Let me show you how many classes Coco dataset for or YOLO Coco YOLO classes. So this will give us the detail. COCO means common object in context. So round about 80 different classes. Some models are 80, some models are 84. 80 classes already this model know. If your problem coming something different, then you need to customize this model, or you need to pre-train this model. I will also record sessions going forward how you can train or fine-tune YOLO model for your custom dataset. That would be next session, or next to next session maybe. So today we will talk about only COCO model. So COCO dataset is 80 different classes this model already trained. Now the question is, this all looks fantastic, all looks good. How, being a .NET developers, how shall I use this in a .NET? Don't worry, this session is especially for you guys. I created a program in .NET which describes exactly this structure. In the .NET, now we finish Colab, export the model, we will download this and we'll use or import this in our .NET program using ONX runtime. Let me open the program. Okay, I opened the .NET program. So this is simple console application, but would be nice for you. It's a clean presentation. So here what I did, I already downloaded two YOLO models, YOLO 8 and YOLO 11. So you can download as many as you want. What dependency you need, this is point to be noted. What references you need to attach. So you need to add reference for ML.NET, Microsoft.ml, ML.image analytics. You need ONX runtime. You need ONX transformer. OpenSharp, OpenCV, I will show you, but this is the later session probably. You don't need OpenCV, Sharp 4. This is OpenCV, this computer vision library for .NET. So for this detecting of object inside the image, you need these four: ONX runtime, ONX transformer, image analytics, and ML.NET. I already prepared a class for you so you can see this. YOLO ONX. Here I downloaded this model. As you look in the Python, it was so simple. just simply writing some lines of code and everything is done. But it's not so simple for .NET, but we can use this in the .NET. So for this I already prepared a program, so you can look here. These are the detections. So I created some properties for this, what the class ID, what the confidence, and then clubbing into one, like overriding this to the string, and where I clubbed concat the string into one, so that give us the idea. And the box, let's say what are the coordinates for the image, which object it detected. Now what are the objects? So these are basically common object where YOLO trained. So YOLO models trained on these common objects. If you have something new, you need to fine tune the model. That will coming soon in the coming session. Here I created a class YOLO ONX YOLO run. It is your name, whatever you want you can give. The model width and height, this basically we need to define it. So generally we prefer 640 pixels, yeah. And then we use inferenciation, as I explained in beginning of the video. Inferencing, we use inferencing. Using inferencing, we will load the model in our program. So we'll use inferencing, and then the model will load. Here we will take the input metadata keys, and then detection. The detection is nothing, it's a customized code. Will use the image or pull the image as in a bitmap format, and then we provide the threshold and threshold, yeah. So the threshold is important. Let's say you can discard the raw, like vague detection if given by the model. So basically this is a more about how you can penalize the predictions, and you can get the better prediction from the model. So this internally, this is little complex here, but you can use this code. That's a ready-made code is available. So you can use this. Detect is basically detecting the object. Apply NMS, this is basically maximizing the penalties, maximizing the minimizing the errors which is detected if something detected by model, and give us the high accuracy. And this is the program. This is not difficult, guys, it's easy. So being a .NET developers, you already know about it. There are some models some methods I use. And then last method I created, this is for detect and overlay. This basically this is basically for overlay, means creating a boundary in a model, in a image. So that will detect the object, and then give us the class name, and then give us the bounding boxes, as well as this will give us the confidence ratio, what is confidence of the model. So let's do that. Let's have a look together. So we'll have this, and here you must need this YOLO model. Yes, one important thing is your model should be reachable. So what I already did, it would be good to know to you. You can make this copy always. This means when you build your program, these will be copied in output folder. And same for the images. I have one image, and I have another image. Let's have a look, yeah. Or let me open this as well, so we can see together. Okay, this will be available here very soon. All right, so there are two images basically I have. One is traffic.jpg. This is traffic image that we have seen there, and one image that I use. So you can use any, but some objects you should keep in the image which are common, or your YOLO model already trained on those objects. So I use this for my last session, yeah. So let's have look here in the go to program. What you need, just enable this. So what I need, I need to provide reference. So now I'm using this, but I can use the YOLO 8 as well. So it's up to me. It's up to you. And here detection, you I just provide the threshold. what the threshold you're providing is 25%. If it's below 25%, discard it. So that's up to you. If you want high accuracy, you can provide the 90, you can provide the 80. Then the detection of object inside the image would be very high accurate here. So this is the one of it. And here it will print after detection happen, then it will print the detection what detected by the model. And if you want, then overlay will be drawn on the image, and then that will be saved as an output.jpg. Let's have a look together. Let me run this program. It will take some time, please bear with me. Great. So you can see here detection already done by model. You can see class is given, and then confidence level is also given, and bounding boxes. So the geometry inside the image where this object detected by the model. If I like to see inside image exactly what is done by this, let's have a look, because it is output.jpg file. Let's have a look here. So here, this is my our customized program, guys. Let me hide my image. You can see the bounding boxes are detected, and you can see the person, car. Can you see car? And then this is bounding box, and give the ratio, means confidence also. What is model confidence? Let's say this is the bus and the model is sure 83%. These are the person and model sure. Based on the object, model have surety. This is the confidence. So model is confident that this is my confident to detecting the object inside your image. Isn't it? Looks interesting. Yeah. So this is fire hydrant detected by 93%. This is the YOLO model. This is, guys, the beauty of computer vision. So in this deep learning session, we use YOLO model, and we import the YOLO model and perform the prediction. I hope this session would be very interesting for you, because something new that's out of the box. Let's continue, stay with the channel, and if you like, then please subscribe as well. You can build your knowledge, just continue your journey together with me and grow your skills. Thank you, guys. Thank you very much. In next session, don't forget, in next session I will record a video for real-time detection. This means we have video, we'll use the webcam, and then our model will detect the object in the real-time video. That would be more interesting. So see you in the next session. Thank you very much.